Even though it's been a little while since I uploaded a 3D printing experiments video, I haven't stopped experimenting. And about 2 months ago, I finally got this Tina 2 Wi-Fi edition working. I got these from an e-waste recycler, and this one came pretty much fully working. It's the basic model without a heated bed. But this one came too. They were like $35 each if I bought two, so I couldn't resist that. And it seemed the only thing stopping this from working was the circuit board in the back. Now, it also had some other issues with it. For instance, the front was, the hot end was coming off. But I removed the hot end, and then I pressed the bearing back in with a clamp. And I used a pair of pliers to hold the bar away. And that actually worked really well. I transplanted the Bowden tube from the Tina 2 to the Tina 2 Wi-Fi so I could test it out. Then I tried to take the old board off of the basic Tina 2 and move it to the new Tina 2 Wi-Fi, thinking that maybe it would just be a drop-in replacement and I could just have at least one printer or I could copy it. But it turns out that the board has changed a little bit and there's a new connector, which is a good thing. They've done some good upgrades to it. At this part, I started building my own circuit board, and I happen to have a pack of colored header pins, so I took advantage of that and made a kind of interesting little prototype board. Now, the first circuit board I built didn't go well at all because the solder I was trying to use had oxidized. I eventually just threw it away and built another board. I wired everything in an identical way. However, this would prove a failure. Upon boot up, the microcontroller had an error reading of both temperature sensors, reading minus 14 degrees, which is, I believe, 0 volts. I posted a video asking for help. However, I did get a few wrong suggestions, and one suggestion where it's an example where somebody forgets the goal, and they said I could remove this ESP32 module because I had mentioned that I want to take this out because I don't need the Wi-Fi and I could use this for something else. And they said I could do that, but I'd have to download the firmware and recompile it and change it to not need it. No, you don't. I just removed it. It's fine. Don't forget your goals. You don't have to go through the hassle of recompiling the firmware. Just rip it out and see what happens. And it turns out it doesn't even give an error message. It doesn't even check unless you click on the whatever Wi-Fi setting. So no, you don't have to recompile the firmware for it. You just take it out and you have a free ESP32. So that's a third little gadget I got from this lot. At this point, I started reverse tracking the pinouts from the components on the main circuit board to the actual components at the front end of the 3D printer, and I started to figure some things out. Please note that the schematic I showed in that clip was wrong. You can actually see, that's how I was connecting it up, and some of that, I detected it wrong because whenever you turn this thing on, some pins are held at 12 volts and then they go active at 0 volts, or they're brought to minus 12 volts and you think they're 0 volts. So it took me a little bit and I hooked things to the wrong pins, and also the fan wires, I just flipped them around for ease of soldering, but you can wire them up however you want. At this point, I was able to get the thermocouples to work, but it only worked when it wasn't printing. When it was printing, it would move one of those pins high or low, and no longer did it have the 12 volts it required because I didn't connect it to the 12 volt power rail. I must have connected it to something else. Now, as for this big connector that provides quite a bit of power, I had seen somebody else was making a prototype board or a custom board on their own on Reddit, and they had asked what kind of connector that was, and they didn't seem to find an answer of what it was. And again, this is another instance where don't forget your goals. It doesn't matter what connector it is. If you're not building these in the hundreds, then you can just, I have a soldering iron and wire cutters. I don't care what connector it is. No matter how weird your cables and connectors are, you can always bypass or jam something into them. And in this case, I really hope that person got around that mental barrier and just realized there's actually enough wire, you can just clip the end off and solder it directly to something. But that's what I did, and that saved me a lot of hassle because people were getting deep in the weeds about finding what connector that was. And at the end of the day, you just kind of got to give up and be like, I can just snip it. At this point, it seemed to almost work. However, whenever I would print, sometimes it wouldn't turn the fan on, and it would also interrupt the bed leveling. So I still had a few more pins that I had to reverse engineer, and that took me another 2 weeks of just, because this reverse engineering for this really kind of made me fed up. And honestly, I could only do it maybe like 45-minute bursts because I would just get really, really annoyed by it. And it's a real pain to have to check something while it's working. And, I kept being a bit annoyed because I have a perfectly good 3D printer. And this was just having the weirdest little issues. But I finally got it figured out. And the last issue, well, we're having issues with the bed leveling. I had issues with the bed leveling before because I had the bed level sensor connected to the wrong power input. And so like in this clip, whenever it goes down too far, it starts to crunch the hot end into the build plate. And I actually have to pull the power. So don't worry, the power didn't go out in that clip. It's just that I pulled the power right then just because it clearly didn't stop. So I fixed that. That was the last thing that I fixed, where I had it connected to the wrong power rail, to where it wasn't a power rail, it was to some GPIO or whatever that happened to be at the right voltage. But it does still have the issue that it doesn't read the bed. So my fix, unfortunately, is just to have a piece of doubled over aluminum foil underneath. For some reason, it just cannot sense the aluminum in its own bed. So I'm thinking maybe the bed leveling sensor is going bad or something. And I even checked the bed leveling sensor, so it's hard to say. This does have an unfortunate ramification that now the build plate is kind of slippery. But at this point, I finally have this $35 printer to where I can print, I can just let it go, and it can produce as many washers and tiny little things that I want. And I don't have to bother my big 3D printer, because if I print a lot of big things on my 3D printer, I try to space them out so I don't wear out any specific section of my 3D printer. I don't get that worn out hole in the very center of the print bed where a lot of people do, because they always put the item in the middle, or you wear out your belts or anything in an uneven fashion. But with this, if I'm printing something tiny, I don't care about wearing this thing out. And if I wear anything out on it, it's so tiny that it'll pretty much be wearing evenly. It's funny, whenever you have to print something, just for the sake of it, it's hard to decide what to print. So I'll print this little CD jewel case holder. Should be a shame if this messes up after sitting for a few months.
Oh, I know.
Honestly, having the print bed automatically heat up honestly makes this way better than this one. This one, it's a little difficult to use, honestly. I'm saying honestly a little too much. Honestly, yeah. You can tell, honestly, whenever I really don't feel like filming, because I get very simplified with how I talk. Yeah. Oh, right, I forgot. I actually made a special print just for preheating. I hate that whenever you stop the print, it just turns everything off and turns the fan off, even if the hot end is hot. It's a bad design. I forgot. I made a setting called Tina to preheat. And I'll share that in the description as well if you'd like. Because I noticed that with this printer, it just doesn't flow the heat to the whole pad quite fast enough. And this one, it has a series of beeps throughout as it heats up to notify the end user. Oh,
what was that about?
power dimmed.
Huh.
Well, there we go. It beeped once. Power went out again. Are we going to have a 3D print today?
I don't know.
Huh. Unless some motor in the apartment complex is stalling.
Huh.
I hate how it still says that it's printing, even though it's stopped. So the temperature will go down even whenever it says it's preheating. So you just have to know after that beep. That's why I added the beep, is because even though it says it's still printing, you press the button and it pulls up the menu as if it's not printing, because it's just stalled. And this is one issue I've noticed. It doesn't have enough strength to actually push the filament in, so it misses steps. That may be an impedance issue, but I don't know. It's hard to say, honestly. I've checked the print head and it doesn't seem like it's too clogged, but I'm deciding just to go ahead and take off this little fan plate, and that way I can get to the bottom, because you can't grip around it, unfortunately. Oh wow, this nozzle is absolutely stuck on here, so I'll have to take it off yet again. Well, this has become an absolute nightmare. I cannot get this off. It's just stripping out of wrenches and all sorts of stuff. What an absolute nightmare. I finally got it disconnected. Now I remember why I didn't do it before. But, yeah, I finally got it undone. Had to preheat it and basically chew it up, but I got it apart. Well, I was able to heat it up with the stove, and I pulled out the big plug. It doesn't look bad, but I don't know. And then I took a resistor, which the wire is thin enough, and I can poke it through. So it comes out pretty well. Okay, so, I mean, I don't know what this... Move down here. I don't really know if that was much of a culprit or anything, but maybe I'll just set the hot end temperature higher as well. Oh, that's interesting. There's a bunch of air bubbles in it, or something. Now I can go back together, and I might just try 230 degrees, honestly. You know, this is kind of what I was afraid of, is that filming this video today would entail more 3D printing experiments today. And here I thought I had this thing working, and I knew it wouldn't just keep working. There'd be something odd about it. I turned up the temperature, I resliced it, and now I'm just gonna kind of cook it, and I'm just going to expect that it has very bad heat flow. Oh, whoops, I forgot to put the Bowden tube back in. Well, that's worrying. I can't manually feed it through the end. So what is going on here? This is weird. Wait, why is this at 150 whenever it's... The programming of this thing is so annoying. So I lose a lot of that heat just on the bed leveling being at 150. Well, I just had a bit of a crazy moment where right as it was setting up, I decided to throw away this plastic, and it actually snapped off right here, so I was able to yank it out, but then I was having a hard time putting it back in because I couldn't actually push it in by itself. And well, whenever I got that in, I was able to push it in, so there must have also been something different about the plastic at the end of this, which it's just a thicker bit at the end. It's not discolored too much, so I don't really know what's going on with that. And because I forgot that technically was still some of that plastic that clogged at the end, and now it's printing well. Look at that. Going super slow. Getting fancy with the label maker. Oh, this is so cool. I'm actually filming these clips after everything else, so for the rest of the video you won't be seeing this, but I figured I'd put it here because that way the people who don't watch to the end don't miss it. And there we have it. Now every single clip in the rest of this video will not look like this, but you can know that after the very end of the video, I did that. And I thought that this was cool enough to show in the middle of the video. That is so interesting. I didn't know that the quiet mode on this one actually made the servos quiet. On the other one, whenever you initiate quiet mode, it still has the very audible and honestly a little bit nostalgic feeling sound of like... But this one, it seems they even lowered the pressure on the servos. Or something. Maybe they curve the waveform a bit to make it not so abrupt. Oh, this is a neat shot. Look at this. Let me see. This is pretty cool. Oh, it's kind of cool. Oh, there we go. Missed opportunity in having the presentation align with the switch. They could have the switch in the front, so you don't have to do that. But, so that's it. It's working, finally. Okay, fine, whatever. Not bad for everything else being free, and I got an ESP32 out of the deal. But I think this can be a pretty useful little machine, just as long as well, now that I cracked that nozzle off, it's not going to be an issue. Oof, this is tough. I have no idea what filament that is. Didn't even check. It might be tough PLA for all I know. Pretty good. So there we have it. We have a 3D printer that now works. I didn't have to buy the circuit board for it. I was able to just go off of a picture of the front of the board and then a few hundred, feels like, multimeter readings and a bunch of scribbles, and I was able to make my own board. And it seems like it's working pretty well. Now the issues with it are just the normal issues of it being a very cheap printer. And yeah. I hope you guys enjoyed this video. I'm just going to say quick video, but it's not quite a quick video. I hope you guys enjoyed this video about 3D printing experiments, and thank you very much for watching. See ya.